talking about the first derivative test. And it's right here at the top. It says let C be a critical value for F, and suppose, this is kind of standard for what we've been talking about lately, F is continuous at C and differentiable on the open interval from A to B containing C except possibly C itself. So this is a little kind of a loophole here. It might not be differentiable at C, but everywhere else it definitely is. Well, if these things are true, oops, and then the derivative of F changes from positive to negative at C. Right? So if it changes from positive derivative to a negative derivative at C, there's going to be a special kind of point there. So let's kind of think about this. If the derivative is positive, that means the function is increasing. But then if it changes to a negative slope, negative derivative, then it's decreasing. What kind of point do we have right here where it changes? A maximum, right? This is going to be a local maximum. If the derivative changes from positive to negative, we have a local maximum on the original function. Right, so we see over here, our derivative is negative. Over here, derivative is positive. And it changes at this point. And this point is where like the derivative is 0, or it could be the derivative does not exist. Right, if we have a sharp turn. So the other one, if the derivative of F changes from negative to positive at C. So we're negative, then positive. On this side, derivative is less than 0. This side, derivative is positive, greater than 0. What kind of a point do we get? Local min. Okay, so derivative changes from negative to positive. You can kind of do it with your hands. If your slope is negative, then positive, you know at that point where it changes, you get a minimum. If it's positive, then negative, then we have a local max. Now the third one says if the derivative is greater than 0, positive, or the derivative is less than 0, negative, for every x except for C, then there's no local extremum. So that just means there's no local max or min. If the derivative is positive the whole time or the derivative is negative the whole time, it doesn't change. Right? So if the derivative doesn't change, that means there's no local max or min. So we're going to look at a couple of scenarios for each one of these three down below. So the first one, 1a, is when we have a function that's increasing, then decreasing, and it changes when the derivative is 0. So here, our derivative is 0. On this left side, derivative is positive. And on the right side, the derivative is negative. So we end up with a local maximum. Right, so in this case, that happens when the derivative is 0. That's when it's changing from negative to positive. Well, it could happen like that only when the derivative does not exist if we have like a cusp. So here at C, the derivative does not exist. But on the left, the derivative is negative again. And on the right, the derivative is positive. I'm sorry, I switched it around, didn't I? Yep. Sorry. On the left, the derivative is positive, and on the right, the derivative is negative. So when we change from a positive derivative to a negative derivative, we have a local max. For 2, this is where we have the local min. That's when the function is decreasing and then increasing. So that can happen when the derivative is 0. On this left side now, the derivative is negative. Right side, the derivative is positive. Right, so we end up with the local minimum, HC. And again, we could have like a sharp turn or a cusp at C where the derivative does not exist. But as long as it changes from a negative derivative to a positive derivative, then we end up with a local minimum. And then our last scenario, 3, is a little bit different, where we don't have a local min or a local max. But we still have a critical value. So that means the derivative could be 0 or the derivative does not exist. So one way this could happen is if the derivative is 0, we could have a graph that looks something like this. So right here at C, our derivative is 0, but the rest of the time the derivative is always positive. We have a positive derivative everywhere else. So since the derivative is not changing from positive to negative or negative to positive, we're not going to have a local min or a local max. Similarly, we could have a derivative that does not exist. So we could have a graph like this, where at C, we have a vertical tangent line. So the derivative does not exist. But everywhere else, our derivative is negative. Alright, so the derivative doesn't change signs, except at that critical value, then it's not changing from positive to negative or negative to positive. We do not have a local min or a local max.